finishing the weekend project I started a couple of weeks ago will be possible now, I think. I just received the final puzzle, or I should say the final piece of the puzzle, not too long ago, a few days ago, and it's actually this. Now it's really, really small, and I'm going to show you what it is. This, believe it or not, this tiny little thing you see here is an FM radio. Now, can you believe how small this is? I mean, this is ridiculously small. But, as it turns out, it's perfect for my purpose. Because, as you remember, I built a small AM transmitter, which is this. And I'm sure you'll remember I built it into a light bulb housing. Now, I needed a sound source, and I decided, well, partly out of curiosity, partly out of, well, let's say a little bit of whimsy, to use a small FM radio to provide sound input. And I was pretty confident I would be able to find a small radio that could fit inside this light bulb housing. And as you can tell for yourselves, I did. Because if you compare it next to the PCB of the transmitter, well, you see, it fits perfectly, you know. Size-wise, it's really perfect. So what I need to do now, actually, is to first of all figure out how this thing works. I mean, there are a couple of buttons built on the back of it, and well, it's a little scan radio. Okay, so you're supposed to be able to scan the whole FM band at the push of a button, and you should also be possible to increase or lower the volume by pushing one of these buttons. I even suppose one of them is a kind of an on-off switch, but off the top of my head I am not capable of telling you yet which one it is. Anyway, I'm going to use this little radio as a sound input for my little AM transmitter. Now, once I figure out how the switches are wired, I'll wire it up to the power supply on the little PCB here, and I'll also wire the output of it, at least one side of the output, to the input of the modulation of my AM transmitter. And then we'll have a go. We'll test it. If it works the way I think it should, then I'm going to consider whether I would build little push buttons on the outside so that I can close it completely off, or leave it as it is and then open it up every time I want to switch channels. We'll see. So let's first figure out how this little FM radio works. First, I had to try the little radio module on its own. Yeah, I had to figure out first of all how it functions, and I also had to sort of make an appraisal of its capabilities. And I must say, for the tiny little size it has, I'm impressed. I used a cheap pair of, well, an old pair of headphones to connect up to the jack connector, which is on the little radio. and I connected it up to a small battery holder with two 1.2 volt rechargeable batteries. So I and the batteries were fully charged. So I was pumping in somewhere around 2.4 volts in it, although it is rated for 3 volts. Now, well, like I said, I'm really impressed. Okay, it's not hi-fi quality, but still, um, I can receive quite a number of radio stations. And okay, the volume is not booming loud, but for somebody with a pair of good ears, I think this is plenty loud enough. I myself am, growing deaf. I hate to admit it, but that's the truth. So I don't hear very well. And I must say, I understood every single word that was being sung. And what's more, I could hear the music clearly. So that's saying something for this little thing here. So, like I said, I'm impressed with its capabilities. Okay, granted, a hi-fi buff will probably say that the quality of the sound is not very great. But hey, you know, for a cheap, tiny little radio like this, well, believe me, it's nice. It's really, it's good. It's really good. Now, I also figure out what the functions are of the buttons. Now, I'll make a close-up. So, if you look carefully at the PCB, you'll see on the right side, the rightmost button has a P symbol over it. Well, that is the on-off button. I suppose the P stands for power. So yeah, with that little button you switch on the radio or off. Then the next two buttons from the right, you see between their pins on the upper side of the PCB a V letter. And if you look really closely, you can see a little plus and minus symbol. So actually those two buttons are for the volume. Now the volume is digitally chosen, which means that you have, I'd say about 7 or 8 volume steps. So from absolutely nothing, so total silence, to maximum volume. Now, like I said, this radio is not a boombox, okay? So don't expect any huge volume coming out of it. Still, you can set the volume by pushing the two little buttons, so the second and the third button from the right, to a satisfactory level. And then you have the two leftmost buttons, and you see between the upper two pins the letter F. Now, actually the letter F is a bit of a misnomer, because I think it stands for frequency. But okay, technically you could say they are right. You're changing the frequency at which it receives. But in this case, I would have called it S for scan, because this is what it really is. This is a tiny little scan radio, okay? So, well, F with the F buttons, so the two leftmost buttons here, you scan for a radio station. And that's it. So, power or on off, volume, more or less, and then frequency, less, more. It's reverse in respect to the volume. Okay, then you have two more contacts for the voltage or the power itself to be connected to. Now, I think you can just about see it, but hang on. On the leftmost right corner, you can see a tiny little plus sign. And that is where you connect the positive side of the power supply. And then the other side, it's certainly clear which is which. So the upper this time is the positive, the lower pin on the utmost right side of the PCB is the mass or the negative side of the power supply. Now, these little things I think are pretty forgiving in the amount of voltage you put into it and the impedance of the headphones you connect to it. Still, if I were you, I would never connect up more than, say, a power supply that gives off more than, say, 3.5 volts. Any more voltage and you will almost certainly blow up the integrated circuit you see there. It's an SMD circuit, and they scratched off or well hid the type number of the chip. I suppose with a little bit of research I could find out which chip it is. In my opinion, it's probably a TDA clone, which is on this little PCB. But anyway, the essence is this. So I figure out what all the contacts do and all the buttons do. And I also figure out that the rightmost contact you see on the headphone jack is mass. This is the right. The second contact is the right side speaker. The leftmost contact is the leftmost speaker of the headphones. Okay. So what I'm going to do is I'm going to drill tiny little holes with my mini drill over equally spaced spacings, let's say, on the dome of the light bulb case. And I'm going to install on the dome tiny little push buttons like these. I bought a whole batch of these, and I'm going to install them one at a time through the tiny little holes I'm going to drill through the dome here. Yeah, I marked the spots where the pins need to come, and I'll just drill with my mini drill all the holes first. Then I'm going to insert each button one at a time, and I'm going to glue them to the dome of the light bulb with a tiny drop of super glue gel on the back side of the switch. So I will glue the switch's backside to the top of the dome of the light bulb. And then, when that is done, I'll connect up each little push button, and I have 5 of them, with wire wrap wiring to the little PCB of the radio. So that's the next step I'm going to take. Just in case you're wondering how I managed to to draw the exact position of the little dots? Well, it's quite simple. I took one of the push buttons and I held it on the inside of the dome like this, yeah, and where I saw the ends of the pins, okay, hang on, so I held it like this, okay, and where the end of the pins are visible, I set with an alcohol pen a tiny little dot. So that's how I know exactly where to drill, okay? So there's really no secret as to how I did it. That's how I did it. So now I'm getting ready to drill the holes, and I'm going to show you how I drill one or maybe two, and then I'll continue later on when I'm done. So this is really quite a hard plastic. So what I'm going to do is I'm going to start at low speed first, and then once I score the surface of the dome, I will try to go at a higher speed if necessary. Okay, here we go. This is harder than it looks, you know, because the plastic is quite hard, so the drill is dancing about quite a bit. So let me see. It's not as easy as it looks, okay? Yep, there you go. This is the first hole. Okay, now the second one.
As part of Greatest Generation season, the men and women who made our world what it is today tell their stories.
Okay, so you need to push quite hard to avoid the drill to dance about over the surface, okay? So here we go. Oh! Well, as you can see, it's far from evident to drill a hole, but okay, here we go. Hopla, another one drilled. And that's how I'll continue drilling round and around, all around the dome. Okay, so the first 4 holes are drilled. Granted, it doesn't look very aesthetic, but okay, this is an experiment, you know, so it's really not important. Now, let me see. I'll take the first switch. I straightened out its pins so that they stick out straight. And let's see if they fit in the little holes I made. Hang on. Hang on. I'm trying. Yep. There you go. So, that's how it looks. Let me give you a little bit more light. So, this is how it looks. Okay? So, I'm going to continue drilling holes and mount switches all around the perimeter of the dome of the light bulb. So that's how I'm going to do it. Okay? I finished wiring up the little FM radio module, which you see over there, up to a whole series of buttons on the outside of the light bulb dome. And that way I can control the FM radio module with little buttons on the outside of the dome. It has two functions really. One, it means I can close up the dome and not have to touch any part inside of it, since there's virtually AC power all over the circuit and inherently unsafe. Secondly, although the little module has buttons of its own on the underside of the PCB, they are really tiny and not so easy to use. These little buttons are slightly bigger and spaced apart a bit more, and therefore easier to use. Now you'll notice that I used a type of push button that is normally intended to be mounted onto a PCB. There are several reasons why I did that. First of all, they are small, and I think they are rugged enough and safe enough to use. Also, they were reasonably cheap. I bought, I think, a bag of 100 pieces, which you see over there, and I only paid a few dollars for them. So since this is only a prototype I'm building, that's okay. Now, the highest cost really is, believe it or not, this little FM module. This is about half the cost of the whole project. It's a pretty rugged little module. I soldered onto it all the little wires you see running there. I did secure a grounding to my soldering iron, just in case, because as we all know, chips, especially SMD chips, are quite sensitive to electrostatic discharges. So also you shouldn't heat the contacts for too long, since the parts on the PCB are much smaller. Excuse me, since they are SMD parts, and therefore heat is much more detrimental to them than normal parts, because normal sized parts like those can evacuate heat much more efficiently, since they have long leads and a bigger surface. Anyway, I connected the module and the buttons, or rather I tested the module and the buttons by connecting it up to a battery holder you see over there, and inputting my well, you could say, how do you call that again? My earphones. And it worked perfectly. So I could use the little FM module with these buttons. So all the functions are available via these push buttons. So what am I going to do next? Well, now comes the real proof of the pudding. I'm going to connect up the little FM module to the power source I built in there. And then we're going to try whether it still functions. When that is the case, then I'm going to connect up the sound output, which are these two leads you see here, to the input, modulation input of the AM transmitter over there, and then we can test the whole circuitry in one go. So let's cross our fingers. I need to make a small modification to our small AM transmitter, which is sitting there. The tiny little FM radio consumes quite a bit more power, well, to be more precise, draws a lot more current than the original design I had made would be capable of delivering. So I had to make a sort of a secondary power supply for the FM radio, which I did, which is there on the breadboard. Don't worry, I'll post the schematic at the end of the video. Anyway, the secondary power supply, which you see over there, is really very, very simple. It's built around, my favorite type of transistor, which is a BC547 NPN, and it only has a multi-turn potentiometer and one resistor. So it's a really, really simple variable power supply, you could say. So I'm going to transfer those three parts to the board you see there, and then once I transferred them and wired them correctly together, I'm going to connect the power supply up to the little radio over there, and then give it one more test, you could say a dry run, and if it still functions correctly, then I'm going to connect one of the output channels of the radio to the modulation input of the Colpitt's oscillator transistor. And then, technically speaking, we should be able to transmit music over the AM band. Aside from making the secondary power supply, I also had to make a little modification to the primary power supply, that which supplies actually the whole design with raw DC power. Now, as you can tell for yourselves, I have two safety capacitors instead of one. And the reason is quite simple. I made a quick calculation with a relatively simple formula to see how much capacitance I would have to use to be able to produce enough current for the whole design. Now, as you know, I'm not only powering a small AM transmitter, I'm also powering an LED, and besides that, I'm also powering a little FM radio, which you see over here. Okay, so after doing a little bit of math, I found out that the original capacitor, which you see over there, which is a 0.1 microfarad, would not be enough. And since I wasn't quite sure how much current the whole design would draw, I over-dimensioned the capacitance a little bit, and I tacked on 680 nanofarad or an 0.68 microfarad in parallel with the original safety cap. So I brought the capacitance up to around 780 nanofarads, or 0.78 microfarad. And it turns out that that does give enough or provide enough current for the whole design. So the transmitter, the LED, and the radio. Well, at least theoretically. I haven't tested the whole of the design in one go. I only tested up to now separate parts. So that's my main goal. So I'm going to transfer now all the parts on the breadboard to here, connect it up to the radio, and then give it another shot. So here we go. Well, I transferred the secondary power supply for the radio to the PCB. Let me see if I can focus correctly. Give you a little close-up. So as you can see, I transferred the parts to the PCB, and I hooked up my multimeter to the power supply, as you can see there, and I'm ready to check the voltage that comes through. So right now you can see there's still a little bit of voltage seeping through, but in my opinion that's the charge on the capacitor. So no big deal there. So in effect, actually maybe it should even be handy as a kind of a memory backup voltage, so if I select a certain station on my little radio over there, having some residual voltage in the capacitor might function as a sort of a memory backup, maybe, I don't know. Oh, by the way, I did measure the current the radio draws when it's shut off. Now, logically you might expect it to draw nothing, but it actually seems to draw about 400 microamps, which is strange in a sense. I really don't know why it would do that, except perhaps to remember the last selected radio station, perhaps, or the settings in general. I don't know. Anyway, the rest current of the radio is 400 microamps. Anyway, so there we go. Let's switch it on and see how much voltage it gives when we switch the power supply on. Let me zoom out. Okay, so watch the meter. There you go. Almost exactly 3 volts, which is what the radio is rated for. Well, actually, no, the radio is rated to function between 2.4 and 3.3 volts. But I think 3 volts is quite a good setting for the radio. So yeah, and the LED works too. Let me show you. As you can see, we can't test the transmitter yet since there's no modulation. So, and you can't hear a carrier signal. Okay, you would just hear silence. So okay, what I'm going to do next is wire up the radio to my secondary little power supply over there and then test it out. I'm going to try something I never tried before, and that is to give you a idea of what I'm dealing with here. Whenever you're going to solder something this small, you really need a few tools like a magnifying glass and a crocodile clamp, which you see me using right now, a soldering iron with a very thin tip, and if possible a steady hand, which is not so evident as it may seem. Okay, so that seems to work. Okay, so, well, as you can see, if you're going to work on something that small, you really need a lot of patience, okay? Because if you don't have patience, that is, well, you might make a catastrophic mistake and ruin everything, and that is not so good. So what I'm trying to do now is to connect the plus wire to the radio, but that isn't as simple as it looks, because like I said, it's mighty small and it's not so simple as it looks. Okay, I hope the image is steady and sharp, but okay, well, it's a test anyway. So. Okay, that's a success. Okay, so I soldered the plus wire. Now I need to solder the ground wire. Well, I was nearly there. In fact, I was gearing up to give you a demonstration of my mini AM transmitter when, well, I had a little, you could say, accident with the whole thing. I had namely forgotten that the whole thing was still connected to the AC, and I had not put a separation transformer between my variac, to which my AM transmitter is connected to, and the AC. I then proceeded to solder this lead which you see here, which goes to this little capacitor here, which is in fact a separation capacitor between the input of the radio frequency transistor's base and the audio output of my little FM radio. And there was a very nice blue spark, not a huge one, but still quite visible. And of course, the safety fuse in the house, which they call, if I'm not mistaken, a ground leak fuse protection, blew. But unfortunately for me, the damage was already done, and more specifically, the damage was done to the little radio you see here. I suspect that the chip just took the brunt of that spark and, just blew. There's no life from it any longer, unfortunately. So I can't give you the demonstration right away of my prototype transmitting music through the AM band. It works. I tried it already, so I know it works. Anyway, that is something you still have to get from me. So a final little demonstration of its capabilities. And I'm excuse me. And I'm quite confident I can give you that demonstration. Now, there is another quite clever detail about that radio, which is that you would tend to think that the radio functions with or without the earphones, and you'd be wrong. Apparently, the design is that clever that when there is no audio jack inside the radio module, then it simply switches off. Yeah? So if there is no earphone connected inside of it, there's probably somewhere at the end of the connector bank a tiny switch. And if there is no jack inside, pushing that little switch, well, I don't know, down or deeper or whatever, then the radio simply doesn't switch on. I had to think a little bit how to fix that, sort of, and I came up with the idea of making a fake jack connector, something like this, yeah, which I can insert into the earphone jack like that, all the way down, and then the radio does function. Well, I should say did function, because, well, like I just said, the radio blew up, unfortunately. As it happens, I had a sort of an premonition this would happen, and I ordered just last week a second little FM module like this. You could say just in case, and indeed it now looks like I will have to mount another FM module inside of this AM transmitter. Now, what I am going to give you to end this unfortunate non-demonstrative video is a little bit of explanation of the modifications I had to do to make the FM radio work, and also well, explain to you how I came to calculate the capacitance that I needed to provide enough current to the whole circuitry. I mean the transmitter itself, this part, the LED you see here, and the FM radio module here. Okay, so give me a minute and I'll set up a schematic. Originally, I designed this power supply to supply enough voltage to the whole setup. You know, the transmitter, which is formed by the Colpitts oscillator, the LED, the blue LED, which lights up when the whole thing is switched on, and then the FM module, yeah, which I symbolized here with FM receiver. Now, the way it was conceived here, it simply didn't allow enough current through to the FM module. So you could say the FM radio, which would provide the modulation signal, well, to modulate the AM transmission. So I came up with this variation. So I built with the use of three simple parts, a say tertiary power supply. So you have the main power supply, which is this one, yeah, which rectifies the AC voltage. Forget about this Zener diode. This Zener diode is not used in my AM transmitter setup. Okay, so so this is of no importance whatsoever. Okay, so this is the secondary power supply, yeah, which I use to supply power to the LED and the Colpitts oscillator. And then this, the third power supply, I use to power the FM module. Now, basically what I want to do is to drop via a 180 ohms resistor. I want to drop about, say, 6 volts, and I want to let through about 40 milliamps. And I calculated it's actually a little bit less that I would need, but I have 180 ohms on hand, so that's what I used. Then I used my favorite type of NPN transistor, which is a BC547, and I used a multi-turn 20 kilo ohms resistor in order to well, to bias the base of the transistor. As you can see, I also depicted the Zener diode output. Yeah, so this one here. So this doesn't go to the FM receiver, but it actually goes into here, into the base of this transistor. And once I did that, and I tweaked a little bit the biasing of the base, the FM receiver functioned perfectly. Okay, so now the main thing is, originally I used an 0.1 microfarad, or if you prefer, a 100 nanofarad capacitor here. Yeah, which I actually use to separate one circuitry from the AC, but also to limit the current that goes through the rectifier bridge and ultimately to the power supplies are built. Now, the way I calculated the final capacitance which I needed, I used a formula which you see here, yeah, which is a reactance formula, which is 1 over 2 times pi times the frequency in hertz and the capacitance in farad. Now, it turns out that when I want to drop about 230 volts AC and I want to let through about 50 milliamps of current at 50 hertz, I needed about 780 nanofarad, which is exactly what I built in. And the reactance came out to be 4081 ohms. Now, I used an internet page where you can calculate those values. I mean, I could have calculated them myself, but there is the URL where you can find this online calculator. Okay? Once I had the reactance of my capacitor, I was able, by using the law of Ohms, or Ohm's law, to calculate the current which would go through the primary power supply, so through this power supply. And it turned out it was not exactly 50 milliamps, but something like 56 milliamps. Okay, so with a simple pocket calculator, I was able to use this law to calculate that it was about 56 milliamps that the 780 nanofarad capacitor could let through. So, I had at the output of the bridge rectifier a voltage of about 10 volts. Yeah, give or take 1 or 2 volts, because the AC voltage has a tendency to vary.